At the end of the previous video, I asked you to work through the mechanism for the ester as it undergoes a reaction with the amine in order to form an amide, and the reaction of an ester as it undergoes a reaction with an alcohol in order to form a different ester through a transesterification reaction. This mechanism right here was assigned for homework, so you'll see the key for that one posted online after the homework assignment is due. I want to go through the reaction here of the ester and the amine in order to form the amide. So like we said in the previous video, esters are not a particularly reactive functional group. And so they require components that are very basic or good nucleophiles or even acidic in order for the reactions of esters to happen. So in this case, our ester is going to undergo a reaction with an amine like dimethylamine. We can use Me as an abbreviation for methyl. We talked about that in class. And the product of this reaction is the amide. Okay, the other product that we're going to get out of this reaction is also the alcohol that's going to be lost from our original ester starting material. So in this reaction, our amine is a very good nucleophile. That means that it can directly react with the ester. And so the amine can attack the ester in this format, but as always, we could also look at the resonance that we have on that initial carbonyl structure. So where those electrons get pulled up to the oxygen, and that gives me this structure here. Okay, now this is the structure that can be attacked by the amine, and that gives us our tetrahedral intermediate. Now, as this tetrahedral intermediate collapses, remember it will always kick out the best leaving group. So from this structure right here, my very best leaving group is going to be this protonated amine right there. So if I need that group to stay bonded to the carbon of my tetrahedral intermediate, I have to remove this proton. So I can use a second equivalent of my amine in order to remove that proton, give the electrons to the nitrogen, and that now gives me this tetrahedral intermediate. So in this case, as I look at this tetrahedral intermediate, I have my oxygen with the negative charge that's going to push the electrons back towards the carbon and kick out one of these groups. If my ethoxide group were to act as the leaving group, it leaves as an ethoxide ion. If my nitrogen acts as the leaving group, it's going to leave as an amide ion. So my two leaving group choices that I have here are either my ethoxide ion or my amide ion. Okay, and the best leaving group is always going to be the most stable conjugate base. So this is the conjugate base of ethanol. So ethanol is the conjugate acid of the ethoxide ion, and the conjugate acid of the amide ion here is the amine. And the way that we know that this is going to be our better leaving group in this case is because we know the pKa of this alcohol is about 18, whereas the pKa of this amine is about 35. So in that comparison, that tells us that this ethoxide ion is the best leaving group from this tetrahedral intermediate. So as it collapses, that's the group that's going to be lost. So this gets kicked back down, that gets kicked out. So as that happens, the product that I get is my amide plus that ethoxide ion that I lost. Now this ethoxide ion that I lost is going to pick up a proton from the species that I formed up here, which is going to be a nitrogen that has two protons bonded to it, so an ammonium ion. Under the conditions of the reaction, this base is going to grab a proton from this acid, and that process gives me the neutral amine and a molecule of ethanol.